Hello and welcome to Dr. T Math. In this video, we're going to have a quick talk, a short discussion, heart to heart, about set theory. And as I understand it, mathematicians can get kind of bogged down in the symbology of how they write things. And so you might see a lot of these symbols in your math class or in your textbook. And I think that they're confusing things a little bit, even though they have a great purpose, right? We need these specific symbols in order to communicate very precise things. However, math being a language of its own in a way, the basic concepts seem to get away from people sometimes. So what I would like to do is just discuss what sample space is in set theory and how that applies to probability, which we're using every day, even if we don't like to admit it or even if we don't know it. What I mean by sample space is, say we've got ourselves some question like, how many viewers or listeners are there to this video? Well, the number could be 0, but then again, I'm listening, so if we count myself, then maybe I'm one of those. Or maybe there are, we don't know how many out there in Cyberland on YouTube listening to this video. But there's certainly whole numbers, because we would have one whole person or 0 whole people or n whole people. And that would form the set of people who are listening to this video. Now, we could just draw a circle around that, and this would be the listeners, call that L. And then maybe some people would be listening, and then others would be watching and following along through, I don't know, I suppose, ideally, people could be like referencing math books and like writing things on their paper and be active listeners. And so we'll call this one maybe viewers as opposed to just listeners. And then there would be that overlap in the middle of people who are listening and watching. And so then we've got a couple of possible sets here. Our viewers could likewise be 0, 1, or n numbers. Now, this space outside is not listeners or not viewers. And if we added up all of those spaces together, that's going to be what's called sample space. And it could be up to the world's population, which is, I don't know, approximately 10 billion or somewhere around there, 9 point some billion. And obviously no YouTube video has ever got 9.2 billion. And I'm not sure that I even hit 9.200 in any of my videos, except for the one of the drag race in Birmingham, Alabama. So, but it is possible. So sample space, that's what we're here to discuss. Sample space is all of the possible things, right? Despite what's likely or despite what we might think, all of the possibles is what we have in sample space. Sample space. It's the space from which we're going to take samples. And by samples, this would include various populations, oddly enough. And so this box in the Venn diagram example for probability is our sample space. That's all possibles, not just the stuff we want to think about as likely, not just the thing that we prefer to happen or whatever outcome we prefer, but all possible. So maybe, for example, you are thinking of a fruit, and the fruit that you're thinking of is a temperate fruit like an apple or an orange, or I suppose orange would be subtropical. So apple or pear or cherry or I don't know, something else from a temperate climate. But also within that category of fruit, within the set of all fruit, we've got this other bit which is called tropical fruits. And before I moved to Thailand in 2005, I didn't know that there were things like durians and jackfruits and mangosteens and rambutans and other fruits like that. Just like some people living in different climates might not know how many different kinds of apples there are, right? There are a lot of kinds of apples. Or some people might not know all of the different berries, certainly not like a thimbleberry, a wild thimbleberry, or an elderberry, or something like that we have in the northern climates, right? But those are all possibles. So why do I bring up sample space? Because a lot of times people consider sample space to be quite limited. And they'll have like this preferred outcome. They'll do this binary sort of thinking, where it's either this or it's not this. And then when people are really fired up, when they're really excited about imagining something, well, maybe they'll imagine a third thing. But they won't imagine that there are literally billions and billions of possibles in so many different situations that could fill up sample space. For example, if we go through our daily lives and we're interacting with people, well, we're going to talk to people, and maybe if we think, well, if I say this, then this person will do that. But it's possible, and then the alternative would be, well, if I say that or I don't say anything at all, then the person will say or do this other thing. And maybe when people are being really open-minded, they'll give a second possible branch for each of those decision trees. But they neglect the idea that maybe nothing will happen at all. Maybe a third thing will happen. Maybe a fourth thing. Maybe an nth thing will happen. And so, and also, there's more than one possible initial action on our part, right? So if we're thinking about what's likely among people, if I say this, if I do this, then this will happen, we're often minimizing the number of possible A, behaviors on our part, initial actions, and then B, responses or reactions from other people. And this happens a lot with unreal conditionals, or especially the third conditional, like if I had done this, then this would have happened, right? The third conditional is the unreal past conditional, where we're trying to change the past. Like if this had happened, then this other thing would have happened. And people usually assert these with a great deal of certainty. Like if, so in fact, like this one thing happened in reality, and then it caused, or it led to some other thing happening, and so we have this final outcome over here. But in fact, and really that's the only thing that could have happened, because that's what happened. But people love to say, well, if this other thing actually had happened, then, well, certainly this would have happened. Or they'll use the present unreal conditional or the future unreal conditional, like if I do this, or if it were this other way, if it's this other way, then this other thing will surely happen. And this is like a bit of wishful thinking, and it's quite a bit of pretend. These conditionals or these hypotheticals are impossible to prove, so they're really convenient, and they conveniently ignore like all of sample space. Not only is it not certain that this other thing would have happened, but there are all of these other things that could have happened, and so a lot of people love to say, like, you could have been killed, or you do you realize what could have happened? Yeah, what happened could have happened, but also nothing else could have happened, because the only thing that happened is what happened. And well, if something could have happened, then certainly there's all these possible things inside sample space that could have happened, including that little blip there that the person is trying to say is the only possible thing that could have happened, and the mere possibility then makes it not only a probability but a certainty. But then it's really quite mind-bending how illogical and unrealistic it is to hyper-focus on one possible out of the billions and billions and billions of possibles in sample space. And so when thinking about probability, again, if this happens, then this will happen, or if I do this, then this is likely the outcome, we need to consider that there are millions and millions of possibilities. And so how do we focus? How do we come to think that, well, this one thing is going to be the outcome? And then sure, maybe we're right, but how did we get to that level of certainty, and how do we get to that level of reliability about complex relationships and complex actions? In order to find the singular outcome that's likeliest, we have to first consider and then sort through and weed out and exclude and eliminate all of these other less likely possible outcomes in sample space. And so rather than, again, focus on all of the terminology and the symbols, I'd like you to just consider that there are so many possible things. And there's, in mathematics and set theory and probability, there's this convenient proof that's not just like somebody trying to tell another person that they're wrong, but there's this convenient proof that is mathematically reliable that there's always so many things that could happen. For example, yes, if I had been looking at my phone, then I could have crashed the car. But what else could have happened is that a meteor could have came from the sky, or I guess it's possible that like my car could have levitated and flown over the wreck that somebody is certain would have happened had I been on my phone, or something silly like that. There's always even the absurd. There is in sample space an element of the absurd possible. So we can't really exclude any of these possibles. Main idea, keep an open mind to all of the possibles rather than focusing on just your preferred one. Thank you. This has been Dr. T Math. See you.